All right, I think we are ready to kick things off here this morning. I am Melissa Garrido, your host today. First and foremost, I would like to welcome all of our amazing guests and our distinguished speaker today, Dan Buckmaster, who is opening up for us for our Buffalo Startup Week on this lovely Tuesday morning. Reminder, this session is being recorded, so please note that, and our Q&A is going to be available at the end of the session. So please hold your questions. Dan Buckmaster, thank you for joining us this morning as president of Tresca Design, which is an engineering firm basically specializing in design and prototype. You found great success with your diligence to be heard. And today you will talk about ways you can evaluate your products and ideas on a low budget, which is important, and minimal experience. So this is quite the opposite of what many of the perceptions we hear today. So it's going to be a great session. And without further ado, please, Dan, give us some insight as you lead us into this new physical product without engineering degree. And the floor is yours.
Great. Well, thank you very much for the intro and good morning, everyone. Very excited and humbled to be talking with all of you here. Today's talk, I'm going to tell you a little bit about how you can make a physical product without an engineering degree and without the costs that you may expect. So first, just a little bit about my company, Tresca Design. I founded Tresca in 2017. I'm an alumnus of UB. I have both my bachelor's and master's degree in mechanical engineering, which qualifies me perfectly to talk about why you don't need a degree to do everything that you think. What we are here at Tresca is we're a team of engineers with design and manufacturing experience across tons of different fields and industries. Tresca itself has two divisions: Tresca Design, which is where we do our engineering and product design, our prototyping, our 3D printing, and then Tresca Global, which is where we work on turnkey manufacturing, supply chain, and operations services. And then below, just a bunch of industries that we currently work in. Again, we don't really niche down to one specific industry. What we do best, we will design parts, we will design assemblies, we can look at analysis of parts, predict how they're going to behave in the field, and then of course we make prototypes to back up all that design work and analysis work we do. But enough about Tresca, enough about myself. Today I wanted to focus on a couple things. First, quickly, lies that you may have been told by people in the industry, including people that have the same types of jobs we do. Second, what is in the design process and how can you adopt it for your own product? And then lastly, I wanted to have a quick session on how you can stop expensive mistakes before they happen. So this is what we're going to go through. And as it was mentioned earlier, I'm going to go through a couple slides here, but I left plenty of time at the end for questions and answers and ask about what I present. You can ask about your specific product. So we're just going to go ahead and get started here. So lies that you've been told. So first, you need an engineering degree. You do not need an engineering degree to design a product. Engineering at its simplest form is problem solving, and I believe that everyone has some sort of problem solving ability. That's what you need. You need a master's degree or a PhD, also not true. Even if you do have an engineering degree, a bachelor's degree is just fine. And even before you get to there, you get through your freshman year classes and you're going to be more than qualified to do this. You need to have done this before. A lot of people will tell you that you're not going to succeed unless you've done this 10 times over. That's not true. Experience, of course, helps. It matters. But if you're smart and you can take lessons and you can learn from people that have done this before, you don't need to do this before yourself. And then lastly, you need a ton of money to make a product. Now, this can be true in terms of getting a product from an idea on a napkin sketch all the way to having 100,000 units in a shelf. But to get your product designed, to validate your idea, and to grow the start of your business as an entrepreneur, you don't need a lot of money. You can do it very cost effectively, and that's what I want to touch on today. So I talk a lot about this design process. What does this actually mean and how can you adopt it? The design process is tricky because it's one process that needs to accommodate every type of product from AirPods all the way up to a water bottle, right? So what does that actually look like? So at Tresca, this is the process that we will use for all of our projects. And this can actually be started and completed at any step depending on where our clients are. So the basis of this is concept generation. So what do you need this product to do? What do your customers need it to do? Once you have a good understanding of the concept, the high level idea, then you go into the proof of concept. You have this idea in your head, you've scratched it down on a napkin. Okay, now go prove that. Go try to figure out how you can validate that. Once you have your proof of concept, then at Tresca, we move into CAD modeling. So this is 3D modeling, bringing your product into 3 dimensions, really getting into the exact science of it. From there, we will do simulation analysis. So trying to test the product before we invest a ton of money prototyping it and making it. Once we're happy with how those go, we move on to a prototype. So this is a mock-up of what will be in people's hands, what will be used by your customers. Once the prototype is good, there's still a phase called design for manufacturing. Just because you can make one of something does not mean you can make 100,000 of it. And while sometimes you can, is it going to be affordable? Is it going to be feasible? And then lastly, supply chain and manufacturing. So you have your design, it's completely ready. You need to find a way to get 100,000 units onto shelves. How do you do that? So again, this is a big overarching process that's supposed to cover almost every product design, but these steps in their own right are basically mini projects. So let's kind of go step by step and talk through how each of these may pertain to you. So starting at the beginning here, concept generation. The first thing you want to focus on is understanding who your customer is. Are your customers individuals? Are your customers a specific group of people? Are your customers a specific type of company? Are your customers in an industry? Who are the people that are going to be buying your product and what are they like? What are their attributes? That is incredibly important to know. Determine the need of your customer. When you know who that customer is, what do they truly need? Are you supplying them something that is a helpful convenience or an absolute necessity? And there's no wrong answer between the two of those, but keep in mind that it should impact your business plan, whether this is a product based on convenience or a product based on strong need in the market. After that, if you and your potential customer agree that this specific product is needed, make sure that you're capturing all their requirements and constraints. What can't they have in the product? What do they absolutely need in the product? And from there, true to the name of concept generation, you're going to start to develop various concepts. My advice is don't rule anything out yet, get creative. If you come up with a concept that you know absolutely won't work, don't crumple it up and throw it in the waste bin right away. Keep it there because you'd be amazed how many times that concept that makes no sense or is virtually impossible can spur other great ideas that are possible. If anyone here has taken an improv group, they've probably heard of the yes and mentality. When you're brainstorming, when you're generating concepts, especially with a group, be very cautious to not knock down people's ideas. Take that idea and try to build on top of it. And eventually you will start to filter them down. That's where we refine ideas. And one helpful tool is what's called a decision matrix. Very simple. You can make this an Excel spreadsheet with 2 different attributes and trying to figure out what the trade-offs are between different configurations. This stage is really focused on figuring out what it is you want to design. You're not doing the designing yet. This is the preparation stage. So the next stage is proof of concept. Quite literally, you are proving that that concept is what you think it will be. So what is a proof of concept? This generally is a physical product that you'll make, and it needs to be cheap, it needs to be fast, and it needs to be effective. Why are those important? Well, in most design projects, your first concept is not going to work the way you think it will, or your customers won't work the way you think it will, or they thought it would. So you will more than likely be making multiple proof of concepts. So keeping it cheap allows you to make more than one. Keeping it fast allows you to not spend 6 months every time you need to change your idea. But you also want it to be effective. You don't want it to be a throwaway. Ultimately, you want to be able to get valuable data and feedback from your proof of concept. So what do these look like? Well, two types of proof of concepts can be a functional prototype and a piecewise prototype. So a functional prototype is a prototype of the complete system, but it's only focusing on the function, right? It's not focused on the aesthetic. A functional prototype for a car may include the engine, the drivetrain, the exhaust, the critical functional pieces. It may not have the nice body panels. It may not have the tinted windows. It will look terrible, but this isn't to evaluate how nice of a car you can make in terms of looks. It's, does your car work? A piecewise prototype is something where, for a car, for example, it's probably going to be very difficult and expensive to make a proof of concept for the whole car, when in reality, your innovation may just be a different exhaust system. So you're going to make a prototype of just the exhaust system, and you're going to evaluate that and iterate that so it's much faster and it's much cheaper than trying to build up an entire car as a functional model. And again, with this, keep in mind that by making it cheap and fast, you are going to have limitations. So what you won't use a proof of concept for, you're not going to use it for marketing, and you're not going to use it for anything related to aesthetics. So this is generally not the model that you are going to bring in front of potential customers, because it is going to look ugly and your customers probably won't understand that. This is a key part of the design process, but very much something internal that you're going to share with your team and your core initial adopters to simply prove out functionality. Two things I show here that are extremely helpful. Buckmaster car. If no one has used this before, Buckmaster has pretty much any type of raw material, hardware, bracket, component, whatever you can think of on that website. It is incredibly helpful for rapid prototyping and simply finding what is out there, what kind of screws are out there, what kind of joints are out there. And secondly, 3D printing. This is something Tresca offers. This is something that a lot of other companies in the area and the world offer. It's a growing market. These are also very cheap. You can spend $250 and get a 3D printer that you can learn how to use in under a week. And that saves you cost right there. So I wanted to also take a quick pause here and mention intellectual property. And as the disclaimer says at the bottom, I am not a patent attorney, but I do work with them quite often. Understanding your intellectual property can quite literally make or break your business model. So make sure you have a good understanding before you start making this public, before you start going out and broadcasting your ideas. Make sure you have an understanding of what your plan is for intellectual property. And of course, the biggest one pertinent to a physical product is patentability. Is your idea patentable? Do you go for a provisional patent, which is a 1-year patent to kind of figure things out? It's quicker, it's cheaper. Or do you go for the full patent, which is going to give you 20 years of protection for either your design, which is how your product looks, or your product's utility, which is how the product functions? This is a critical step that, again, can make or break your business model. So make sure that you have someone that you can trust, that you can speak to about this. There are several patent attorneys in the Buffalo area that can help you here. Most colleges will have an intellectual property office or a law clinic that will help you. I know at UB there's the e-law clinic that can help you here, but it is almost never too early to begin thinking about these, because making mistakes specifically with disclosures can actually land you into trouble when you're trying to patent. So please keep this in mind and make sure that you don't just overlook this. Okay, back to our process here. So we've gone through the concept generation, we've gotten through the proof of concept, and now you're happy. You have this model that you've thrown together. It may be ugly, it may have duct tape and glue on it, but you know what? You proved the concept. What's the next step? Well, some sort of modeling specific to mechanical engineering, CAD modeling, is extremely helpful. So what this does, it allows you to visualize your product in 3D. So it is very expensive to make some of these things, or it's very difficult to make some of these things. And you don't want to keep iterating a single part 20 times. Putting it into a 3D modeling software will allow you to see interactions. The corkscrew is a good example that I show here on the right. How are things going to mesh together? Are you leaving enough room? Is there going to be a little bit too much wiggle? This is a way where you can spend hours and hours in this software to double check it before you go out and get it prototyped. Also, moving on to the next stage, this helps you run simulations to test your product in various environments. So a couple resources here. CAD software can get extremely, extremely expensive. So for some students, depending on the university you go to, SolidWorks or PTC Creo are two very popular softwares. Free for everyone, you can go to Autodesk Fusion 360 or Autodesk Tinkercad. So there are places where you can go and download CAD software for free. There is a little bit of a learning curve, but with any of these programs that I have on this slide, there are countless tutorials, help desks, YouTubes that will walk you through the basics and get you up to speed on it. Okay, so then we get to simulation analysis. So why is this important? Why would you want to simulate your product? Well, iteration is expensive. When we get to the next stage of prototype, contrary to the proof of concept stage, you're going to want to invest a little bit of money in here. This is what you're going to show your customers. This is what you're going to want to show your investors. So you want to do that stage as little as possible. So two ways we can simulate. The first is physical testing. So quite literally make another proof of concept, make a prototype just small parts of this, and test them. Is it working the way you want? This is a good first step regardless, but it's especially good for projects that don't have loads, meaning someone isn't squeezing this, it's not supporting weight, it's not very structural in nature. This is a good way to very quickly say, okay, this is going to hold up the way I want to. For more advanced applications, things where you are squeezing something, things where things will be dropped, we can do what's called FEA. This is definitely a more advanced topic that would take you a little longer to learn on your own. But when physical testing isn't feasible, with your CAD software, you can actually apply loads and you can show, okay, if I squeeze this with this amount of force, this is how much it can resist it. It will or won't break, or it may bend certain ways. So again, the purpose of this step is try to reduce the amount of times that you need to go off and prototype something. And so then we do get to the prototype stage. So what's the purpose of this? Well, you need to sell other people on your idea. You need to show that it's feasible. A lot of times the slides, the sketches, the things that you'll present to someone will only get you so far. Eventually you'll get to a point with your early adopter customers, with your investors where they say, okay, show me, prove it. So prototyping is a big bin, and I listed just a couple different types of prototypes here that may be applicable to your process. So one thing is rapid prototyping. This is the most similar to that proof of concept stage. So quick and easy methods here meant for verifying concepts. 3D prints, you're usually going to discard these after you use them. They're not going to be built for life, but again, it's going to allow you to rapidly change things. If you have 4 different configurations of your product and you're not sure which one your customers will like, rapid prototyping is going to be the cheapest and quickest way you can make all 4 of those to see which one your customers actually end up liking. Next is evolutionary prototyping. So this is most common, especially for larger companies. They will create a prototype, give it off to early adopter customers, give it off to focus groups, then gather that input, revise the design, and make another one. Sometimes this takes 2 evolutions, sometimes it takes 20 evolutions. It depends on the product and how much of your customer input you're willing to accept into this stage. One thing that we find a lot that can trip up a lot of inventors here is knowing when to stop that evolutionary process. When you're starting out, your product is most likely not going to have every little feature that you want in it. And that's probably because the cost is going to become very high. So it's important to understand, when are you going to accept your customer's input and put it into the current product, and when you're going to say, okay, that's great input, thank you for that. We're going to make that in our second generation of the product. We're not going to put it in here. And then lastly, I have incremental prototyping. So you think back to the car. Most car manufacturers will make one prototype car. However, of each individual component, they may make tens, hundreds of prototypes. So understanding that you can prototype individual sections and prove them out independently if you don't have the time or budget to make a big overarching prototype of the system. And so again, there's some options here. So on your low end options, you can get professional quality 3D prints where you can have them hand finished. You can put that in front of an investor and they're going to think it's a finished product. You can go onto the high end where it is going to be a molded or a machined prototype, and it is going to be the real deal, so to speak. That all depends on how much money you have and you're willing to contribute. But again, this stage is where things start to add up in cost. The purpose of the 4 stages that we went through before this, we're trying to make you as confident as possible that when you are going to drop a little bit of capital on a prototype, that it's the right thing to do and that it's going to allow you to get more capital because of it. After you have your prototype and you're happy, your investors are happy, your potential customers are happy, there's still one more step that you need to go through. You need to recognize that there is a gap between your CAD model, your prototype, and what will be manufactured. So designs that are made for 3D printing especially, they don't always transfer well with standard manufacturing techniques. Every manufacturing method has its own limitations, its own benefits. So going through that process and making sure that, again, just because you can make one of a product doesn't mean you can make 100,000 of those at the cost that you'd like, because your one product is always going to be more expensive than when you're buying them in bulk of 10,000 units. So some manufacturing methods for you to consider, the most common ones we come across: injection molding. This is how 90% of the plastics you have in your house are made. CNC machining. Traditional machining, those are dealing a lot with metals and subtractive manufacturing, so shaving things off, cutting things off. And then also casting. This is molding for metal, basically. And so, great, you've gone through that. You have the design that you are confident is going to be good for manufacturing. Well, you can't just send it to one person to have them take care of everything for you, right? You need to work on finding ways to source your product, to figure out the logistics, and to actually get it manufactured. So sourcing, where are your parts going to come from? Who will make them? Your prototype, your proof of concept, you may be able to buy components off Amazon. When you're making 100,000 of these, Amazon is going to get very expensive very quick. So who's the manufacturer that's going to give you that component? Global logistics. This is increasing in criticality, as anyone who's been reading the news can see. Global logistics are frankly a nightmare right now. So due to cost, availability, you will most likely be having some parts made overseas. Getting your parts into the United States can be very tricky, especially now, but even before the supply chain crunch that we're in, it is tricky importing products. It's also difficult to export your product if you're planning to sell outside of the United States, especially outside of US, Mexico, and Canada. So plan on working with someone or learning these processes very well. Plan on understanding how you can interface with a customs broker. Plan on not making these mistakes because they can delay your project and they can have unforeseen costs if you're not factoring in tariffs, duties, and other things that can seriously impact your business model. And then lastly, contract manufacturers. Most people, when they're coming out with their first product, are not looking to manufacture it themselves. To spin up a manufacturing facility is a tremendous investment. It is a huge risk to take on. You're probably going to be using a contract manufacturer. So question is, if you're not making your product, who will? who is out there, either domestic or overseas, that's going to be able to put together this final product for you. Okay, so I know that was a lot to throw at you guys, and the design process can definitely get complex and it changes for every single project. But I wanted to also talk about how can you stop expensive mistakes before they happen? Because what you don't want is to get to step 5 of the process and realize that all the time and money you spent in the first 4 stages was completely wrong. So a question here, where do most entrepreneurs fail in this process? Do they fail in the simulation stage because it's the most technical? Do they fail in the CAD modeling because they're not great at it? Do they fail in supply chain procurement because they missed a due date or things got more expensive? There's a lot of places you can fail in this process, but most often you fail before you even start this process, right in that first stage, even before that first stage of concept generation. That's when most people fail, because they fail to truly understand their customer. So an important thing here is understanding how you can capture your customers' needs and your customers' wants. So this is where my first recommendation is make 2 lists, your user requirements and your functional requirements. Your user requirements are the what. So this is your customer telling you, I need this unit to be used this way. I need it to be used this way. I also need this unit to have this little feature. I want it to look this way. I want it to be this color. All of the things that make up the what of the product. That's your first step. Once you have that list, you're going to move over into functional requirements. This is where you start to do the work and start to make a divide between what your customer wants and what your design is going to need to do. So to achieve those requirements, you need to create a design that has function X, function Y, function Z. This is the how. And the trick here is every user requirement should be covered by at least one functional requirement. It's not going to line up one-to-one, right? To get to use A that I have here on this bulleted list, you may need to have 2 functions. And likewise, function Z may take care of 3 of those user requirements. This can be a little tedious. This can be frustrating. This forces you to have good communication with your customer. And that is the most important thing, because then you have a record and a list of why you're designing things the way you are. You can also use this to filter in between your customer's needs and your customer's wants. So in that list of user requirements, your customer may say, I need this unit to be safe. Okay, that makes sense. I also want this unit to be sparkly and silver. Well, that's a want, that's not a need. So understanding, can you go to market if it's unsafe? No, you can't go to market. Can you go to market if it's not silver and sparkly? You probably can, depending on the product. So this is a critical step that, again, will prevent you from making that first mistake. And many people learn this the hard way at the prototype stage when they've already spent all that time and effort. When if they had taken the time to just sit down and clarify this, they could have saved a lot of time and money. And so I want to close here before we go into Q&A with some questions to ask yourself as you're looking through what I've presented here and you're thinking, okay, how can I apply this? How can I take these pieces and use it for my own pathway? The first question is, how can you better capture your customer's feedback? How can you make sure you're being effective at understanding what your customer actually wants? Next, how can you develop your product using those customer specifications? Something that happens a lot, especially when someone creates a product from an industry that they're familiar with, they skip regarding other people's inputs. Sometimes you'll believe that you know your industry, you know your product better than anyone else. And that may be true, but the question is, do other people think the way you think? Are other people going to find value in the things that you also find value in? Because ultimately, you won't be buying your product. 10,000, 100,000, a million other people will be buying your product. So you need to remember that their specifications are what matter. And then lastly, how can you adapt this design process to your business plan, right? As you're going through as entrepreneurs, this design process is a crucial part of your business plan, but it can't be the whole thing. You need to understand, where are you willing to make investments? How much time are you willing to put towards this? What risks are you going to be mitigating? How can you overcome the challenges as they come up? So starting your product development process and asking yourselves these questions will, again, save you a lot of time and a lot of effort. This is why I say you don't need an engineering degree to do this. Yes, there are some technical things with CAD modeling, with running simulations where you may need help. But in general, you can capture customer feedback. You can come up with a product concept, and you can get very far along on that process without using any engineering help, without spending hardly any money. And that's the purpose, to get yourself confident, to mitigate risk that your product won't work or people won't like your product, so that you can go out and you can fundraise, you can sell your product, you can continue on the pathway. So with that, I'd like to open it up here for an open discussion. We can talk about some of the points I've touched on today. We can talk about your individual ideas. Just keep in mind that slide I said with intellectual property, and make sure you're not getting yourself into any trouble by sharing things here. So thank you everyone for giving me a little bit of time this morning.
Thank you, Dan. What great insight you brought to the virtual table today, and also on helping others make a plan, or even perhaps them make their first decision and next step, as well as tips to avoid, right? So we thank you for your wealth of knowledge today and the information. Yes, so guests, if you have any questions, feel free to unmute yourselves and ask Dan whatever you like. In the meanwhile, I will ask, is there, for your business name, is Tresca, is that from something? Is there a story behind the name Tresca?
Yes, there is. So Tresca is actually named after a French engineer, Henry Tresca, and he invented the prototype meter bar. So for a certain period of time, I believe in the 1800s or 1700s, he developed the bar that was used as the standard for how long a meter is. And his task was to develop a cross section that was geometrically the stiffest possible given the material, which was some sort of platinum alloy. And the cross section he came up with is that little X symbol that you see down there. So we actually have a blog on our website you can go check out that tells the full story. But yeah, there is a little bit of history behind the name and the logo.
Okay, I like it. So are you on a lot of the social medias? How can people find you? Are you available on, I know you're on LinkedIn. Go ahead. Would you like to?
Sure, yeah. LinkedIn is the best place to get in touch with myself and to follow Tresca. Please go give us a follow on LinkedIn. We post one new blog every week that covers a variety of topics on product development, prototyping, engineering in general. And you can also go to our website and see a history of all the blogs we've posted. So yeah, LinkedIn is the best place to get in touch, and I'm always happy to have conversations.
Awesome. Any questions, anyone? See a few people on. Do you have any favorite books or podcasts that you would like to share, or that you resort to, even up and coming? Is there a go-to you have?
Sure. So I don't have any off the top of my head. I've been focusing the last couple months to find a couple good books specific to product development. Same with podcasts, but I haven't found anything just quite yet. So maybe that's something that we start up in the future.
Yeah. Oh, absolutely. And I guess the last thing I have for you is, what would you tell your younger self, starting all over, since you have a wealth of knowledge and found great success, or any advice that you would give to someone up and coming and looking to sell their next product or launch their next product? What is the one thing that you would say to them, or your earlier you?
Sure. I think the advice I would give is very much in line with my major point today, which is make sure you talk with as many people as possible. Don't discount anyone's advice, but don't take anything for granted. What I mean by that is make sure you go out and you talk to the people that are in industry, that may be potential customers, that may be potential adopters, but also talk with mentors. Find yourself a fleet of mentors that can help you with your financials, with your business plan, with your marketing plan. The more people you can, the more people's expertise you can leverage within your business plan, the better. But with that being said, you're going to have a lot of people surrounding you, giving you advice, and more likely than not, it's not all going to line up. So don't fall into the trap of just because one person says one thing that you have to do that. Make sure that you're properly filtering, you're making sure that you're making the decisions that you're comfortable with, and make sure that you're always focusing on taking as much feedback as possible and boiling it down into a pathway that, to the best of your knowledge, you think sets you up for success.
Awesome. Anyone? All right. Well, I guess that'll wrap up today's discussion. So we want to thank both of our attendees and our amazing speaker today. Dan, that was awesome. Thank you so much for your time this morning, and also being part of Buffalo Startup Week. We really appreciate you. For those that are on, please register for the remaining sessions for the rest of the week. We have some awesome speakers to, cover all perspectives. So we thank you once again, and I see you have your contact, so thank you for that. And I guess we'll give you some time back in the day. So you were successful again today, Dan.
Perfect.
Yeah.
Well, thank you everyone, and I appreciate the invite. Honored to be speaking here, and wish you all the best of luck.
Thank you. Thank you, everyone. Take care.